Hello, everybody. We are the ModulSim Smart Home Group. Our members are Bianca Doronilla, Art Gumba, Christian Gonzalez, and John Wilson. This is what we will be talking about today.
So, with the rise of smart homes, was the Internet of Things. So, where everything is connected together, be that our TV, our Roombas, and sometimes even our fridge. There's no doubt been a rise in smart homes over the past years now in the United States. As we can see here in this chart, almost half of the US homes are considered smart homes, with more being built. In 2023, 60 million homes out of every 100 million homes are going to be a smart home. But that begs to differ. There are a lot of people that are being left out. Smart homes are a quality of life improvement, and millions of people don't have access to this. ModulSim provides smart home services to people that are living in older models of homes, rental homes, mobile homes, and apartments. These are people that are restricted by lease agreements, contracts with landlords, or just the financial cost and the lack of time for renovations. ModulSim is really designed for these homeowners who want that smart home capability without needing to spend a fortune or have to undergo these extensive renovations in their house to modernize them. ModulSim is separated into different modules. The current version has light controllers, automatic interior door controllers, automatic garage door controllers, and AC controller, also with a temperature and humidity sensor so our users can see and change that on the go. It's also all controlled by one ModulSim app. Here's a little simple data flow chart just to visualize where all these modules are connected to and how they're sending data to either a phone app or a central terminal or a computer program where our users are going to be able to control everything. So we get all that data from those different modules, whether a door is on, closed or open, or whether lights are on or off. And those data are being sent back into the phone, where then our users can input a command, which will then send via Bluetooth back to those modules and then run everything as needed.
And now, in terms of organization of this project and pretty much our plan for this, is we had to set a very organized timeline of productivity in order to successfully achieve this product. So we pretty much started out in like the phase of just drafting and planning how we're going to be constructing this home. But kind of as you see towards the middle of the timeline, this is when we basically start actually doing the technological side of this project, programming, setting up the sensors and motors and such. And since our spring break presentation, or as you can say, our midterm presentation, we have been putting a lot of work into implementing those Bluetooth capabilities and also meeting up and combining all the technology with the home construction that we had finished prior to that time. And as you can see, based on this 16-week timeline, we have actually finished pretty much perfectly with the productivity that we've been going through for the rest of this whole semester.
As Clark had talked about a little bit, the features that we have in the ModulSim home are lighting that is toggleable from the smartphone app. We have automatic climate control through the use of AC. And we have motion activated interior and garage doors. Now, if you look at these relays here, this is a bank of relays. Each of those circuits goes through one of the relays. So the upstairs lights will go through one, the garage light will go through one, etc. So this is a demonstration of the scale model house. The dimensions of the house are 29.5 inches by 21.5 inches by 10.5 inches. And all of that is mounted on a 18 by 36 inch base plate. The scale home has 4 rooms that each have independent lighting. And then in the downstairs portion, there is an automatic interior door. On the left, you can see the automatic garage door. And then up on the top is the simulated air conditioning system. Sensors and controllers can be used with the ModulSim app or the central house terminal.
And as you can see here, will be providing a visual demo of the modules.
So as for the app development of this program, we utilize MIT's App Inventor program, as well as the HC05 Bluetooth module for the Arduino. And there's plenty of information available online as for connecting these two. MIT App Inventor was a great way to program a simple app, considering that our app only needed on and off switches and the ability to connect over Bluetooth. We were able to accomplish that relatively easily. And we were also able to accomplish communication between the Arduino and the app relatively easily. However, that does not mean that we went without plenty of tests. Because of the cost of both the Bluetooth module and the ease of use of the App Inventor, we ran into many issues with consistent communication. So after many tests, we got it working, but that was an issue that we ran into consistently. So this is just going to be a little demonstration of the app.
And as you can see here, as we've been working on this project, we've had to purchase several items in order to make this become a reality. And as you can see, kind of towards the bottom of this list here, for the construction phase of this project, we had to buy, our plywood sheet for constructing the house. Your screws and the blade for wood cutting. And then for the technical side, we've ended up using our an Elegoo Uno board, and we use a Elegoo Mega board. So those are probably the most pricey parts of this project, but these kits came with a lot of the essential sensors and motors that we used for this project. And everything else that you see here is just our wires and extra sensors that we had to buy along the way. And previously, we wanted to keep our budget below $300 total, and as you can see here, we were able to, maintain budget friendly, as we're pretty much a little more than half of that at $174. So we did a pretty good job in maintaining a very, very low budget for this project.
So the challenges our group faced was mainly due to COVID. From transitioning over a real house like we originally had planned for, we settled to a model scale house. This is because we couldn't meet up regularly in person as needed. We did, however, met up a couple of times to build our house, compile everything up, and do some final testing. Next, we needed to be mindful of the cost, as mentioned by Christian, since we didn't have a lot of the resources that was offered through the school, so such as a fab lab. So we really had constraints in our budget. Therefore, we both needed to be creative and efficient with our money, thus leading us to our small-scale smart home. All materials that we used on our house were downsized and just enough for our budget. And like Christian mentioned, we cut our budget costs in half. However, since most meetings and individual work and testing were done separately and online, there were some resources that we had to purchase multiple times. Like we had 3 different Uno kits so that we can all work on our respective parts. So to conclude our presentation, we had achieved our goals for our senior project while keeping in mind our target audience. Our current ModulSim version is both user and cost friendly. It's fully functional, individual modules working either separately or together with lots of room for improvement. Additionally, our integrated app is also functional via Bluetooth connection, and it's durable. So it can withstand our current environment that our smart home is in. So future plans for our ModulSim is to implement more features like opening and closing the window blinds, door locking and unlocking operations, and to be able to monitor house cameras within the same app. Also, we want our product to be more personal to our users, so we would like to implement personal profiles and compatibility with other softwares. And lastly, to be able to transition from Arduino to custom-made circuit boards. We want to also go back to our original project proposal, which is to make affordable and user-friendly smart homes. So we'll have to scale it back up from a model home to a real-size smart home.
And something that we realized along the way was the ability, while using relays in our circuit, just how many options we would have in a smart home. So devices like lights, fans, automatic motors, those kinds of things, those could all be connected to relays, which would be connected to the rest of our system. So in looking towards the future, that is definitely something we would keep in mind, is using the relays to the best of their ability to make this the most marketable.
And thank you for watching, everyone.